You are working with a dataset containing missing values. Which of the following sklearn imputer classes is best suited for handling missing values in a categorical feature column? A. Simple imputer. B. KNN imputer. C. Iterative imputer. D. All of the above. Simple imputer can handle categorical features by replacing missing values with a constant value, e.g. missing, unknown, or the most frequent value in the column. True. KNN imputer can handle categorical features by imputing missing values based on the values of k nearest neighbors. It considers the relationships between features, making it suitable for situations where the missing value might be related to other features in a dataset. True. Iterative imputer can handle categorical features by using a model, e.g. linear regression, to predict missing values based on other features in the dataset. This approach can capture complex relationships and dependencies between features. True. All the mentioned sklearn imputer classes, simple imputer, KNN imputer, and iterative imputer, are capable of handling missing values in categorical features, each using a different strategy. True. D. All of the above. Missing data refers to the absence of values in a dataset, which can occur due to various reasons like data entry errors, faulty equipment, or intentional omissions. In a medical database, missing patient information like blood pressure or medication history might be encountered. In an e-commerce dataset, missing product reviews or customer purchase history could be common. Consider a dataset with 10 rows and 5 columns. If there are 2 missing values in column 3 and 1 missing value in column 5, this represents missing data. Data imputation is the process of replacing missing values in a dataset with estimated values. The goal is to maintain data integrity and prevent bias in subsequent analysis. In a financial dataset, imputing missing income values for loan applications can be crucial for risk assessment. In a marketing campaign dataset, imputing missing demographics like age or gender can be useful for targeted advertising. Imagine a dataset with ages of individuals. If a row has a missing age, we can use imputation techniques like mean, median, or KNN to estimate the missing value. Categorical features are variables that represent categories or groups rather than numerical values. They are often represented as text strings or encoded using integers. In a customer survey dataset, features like gender, education level, or marital status are categorical. In a product catalog dataset, features like product category, color, or size are categorical. A dataset with a column city containing values like London, Paris, New York represents categorical data. Scikit-learn sklearn provides various imputer classes specifically designed for handling missing values in datasets. These classes offer different strategies for imputation, catering to diverse data characteristics and analysis goals. Sklearn's imputer classes are widely used in machine learning and data analysis tasks, such as preprocessing datasets for model training, enhancing data quality, and handling missing values in real-world applications. Using sklearn's simple imputer to replace missing values in a numerical feature column with the mean of the column can be represented as Python from sklearn. Impute imports simple imputer. Simple imputer strategy mean replace missing values with mean data imputer, fit transform data. Simple imputer is a basic sklearn imputer class that replaces missing values with a constant value, e.g., missing, unknown, or the most frequent value in the column. It's suitable for simple scenarios with limited dependencies between features. Simple imputer is often used for handling missing values in categorical features with low Cardinality: few distinct values, or in scenarios where the missing values are unlikely to be strongly related to other features in the dataset. Imagine a categorical feature gender with values male, female, and missing values. We can use simple imputer to replace missing values with the most frequent value, e.g., male, or a constant value like unknown. KNN imputer is an sklearn imputer class that utilizes the k-nearest neighbors algorithm to impute missing values. It considers the relationships between features and predicts the missing value based on similar instances neighbors in the dataset. KNN imputer is particularly effective when handling missing values in categorical features where k missing values might be related to other features. For instance, it can be used to impute missing values in a customer demographics dataset based on similar customer profiles. Consider a dataset with features like age, income, and marital status, where income has missing values. KNN imputer can identify the k-nearest neighbors based on similar age and marital status and use their income values to impute the missing value. Iterative imputer is an advanced sklearn imputer class that uses a model, e.g., linear regression, to predict missing values iteratively. This approach enables capturing complex relationships and dependencies between features. Iterative imputer is suitable for scenarios with complex relationships between features and when missing values are likely to be influenced by multiple other features in the dataset. It's commonly used in datasets with high cardinality or when simpler imputation methods might not be sufficient. Imagine a dataset with features temperature, humidity, and rainfall, where rainfall has missing values. Iterative imputer can use a linear regression model to predict rainfall based on the values of temperature and humidity, capturing the potential dependencies between these features. Nearest neighbors is a fundamental concept in machine learning, which involves finding data points in a dataset that are closest to a given point. It's used in various algorithms like KNN imputer and k-nearest neighbors classification. Nearest neighbors algorithms are widely used in tasks like image classification, recommendation systems, and anomaly detection. They rely on the principle of finding similar data points to make predictions or classify new data. Imagine a dataset with two-dimensional data points. To find the nearest neighbor of a point x, y, we calculate the Euclidean distance between x, y, and all other points in the dataset. The point with the smallest distance is the nearest neighbor. Predictive models are mathematical representations of relationships between variables in a dataset. They are used for making predictions about future events or outcomes based on historical data. Predictive models are widely used in various domains like finance, healthcare, marketing, and manufacturing. They can be used for tasks like fraud detection, disease prediction, customer churn prediction, and demand forecasting. Linear regression is a predictive model that represents the relationship between two variables, independent and dependent, using a straight line. It can be used to predict the value of the dependent variable given the value of the independent variable.